All right, number 3. A multiple choice test has 10 questions, each with 3 choices for the answer. Only one of the choices is correct. You randomly guess the answer to each question. What is the probability that you answer the first 4 questions correctly? So we've got 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want the probability that we answer the first 4 questions correctly. So 1, 2, 3, 4. Each question has 3 possible answers, and there's only one correct answer. So the probability of answering the first question correct is 1/3. The probability of answering the second question correctly is 1/3. And the probability of answering the third question is 1/3. And the probability of answering the fourth question correctly is 1/3. That leaves us with the remaining questions where the probability, our possibilities for the 5th question is 2/3, because we only care about answering the first 4 questions correctly. And the probability of answering the next one is 2/3. And the next one is 2/3, 2/3, 2/3, and 2/3. Those are all 2/3 because there are 2 incorrect answers and 1 correct answer. So when we simplify that, you get 1 times 1 times 1 times 1 times 2 times 2 times 2 times 2 times 2 times 2, which is 64, out of 3 to the 10th power is 59,049. And when you simplify that, you get 0.001. Number 4. 300 people were asked, do you like math? Of the 133 that answered yes to the question, 114 were male. And of the 167 that answered no to the question, 106 were male. If one person is selected at random, what's the probability that this person answered yes or was a male? And this says to make a 2-way frequency chart. So I'm going to start off with a title so you have the same setup that I do, and then I'll give you a few seconds to finish making the rest of your chart. So we have, our possibilities are yes and no, and then we have male and female. Make sure you give yourself enough room for the columns where we're going to have to get the totals. Alright, so hopefully your table looks like that. If not, go ahead and finish that up. And let's start filling in where we can. So, of the 133 that answered yes to the question, 114 were male. So we're going to look at our yes column. There were 133 of them, and 114 were male. Well, if 114 were male, and there were a total of 133 of them, then that leaves 19 females. Because remember, the total of your column, whatever you put for here and here, it has to equal that total. Alright, next. Of the 167 that answered no to the question, so that is 167, 106 were male, which leaves us with 61 female. Next we have to come up with let's get our totals. Well, if you add 133 and 167, you get 300, which is perfect because that is what our total was. 300 people were asked. And then 114 and 106 is 220. And 19 and 61 is 80. And we can double check ourselves. 220 plus 80 is 300. So now we can answer our question. What is the probability that the person answered yes or was a male? And remember, or means add. So the probability that somebody answered yes is 133 out of 300, or was a male, which then we would look in the male column, and that is 220 out of 300. But then we want to subtract because we counted this twice. We counted it in the yes column and we counted it in the male column. So let's subtract 114 out of 300. So we have 133 out of 300 plus 220 out of 300, which gives us 353 out of 300. Subtract the 114 out of 300, and what we end up with is 239 out of 300, which is approximately 80%.